Hey, pre-calc, time to talk about the next type of conic sections. I'm going to jump up here. This is 4.4, the ellipse. All right. Now, the ellipse and the circle actually have the same equation, so I'm not going to do a separate video for the circle, and I'll talk about that while we do this one. So, an ellipse. Now, remember that the ellipse is if a plane were to intersect, and here's my cone, here's my beautiful cone, where that's a circle base, base-ish, because it does go on forever. But if this were to be intersected by a plane that kind of cuts through it with a line that's not quite as slanted as the original line that made the cone. So if it were to be cut by something like this, I'm going to get this ellipse shape kind of cut out of this. I don't want that to go quite so far. There we go. I'm going to get this ellipse here, and that's where the ellipse is from. So I'm going to draw a pretty big ellipse here. We're going to define a lot of things inside of it as best you can. It's all right. So try to make it as much as you can where these two are the same as these two. It's completely symmetrical. An ellipse. So the ellipse, a couple of important points here. First of all, right here is my center of the ellipse. And then I'm connected by two line segments here. This is called the this is the major axis because it's bigger. Major axis. This one's called the minor axis. It's a circle if the minor axis and the major axis are equal. Okay. But generally, the ellipses we're going to be dealing with will have a major and a minor. So the definition of the ellipse has to do with all of the points around the center. And so if I were to pick a random point here, I don't know, point P, some random point here, and connect that point P to the foci. Because, with the parabola, we only had one focus that it's turning around. Here, I have two. So this is a focus over here. This is a focus over here. So if I were to connect point P to both focuses, to the foci, point P here to point P to the focus over there, I'm going to get two distances, right? D1 and D2. No matter how I move this point P, like if I were to move it over this way, point P, this will be D1 now, and this will be D2, right? You can put that anywhere. If I were to add these two distances, either from the original point or this point, it will always be the same constant number. Okay, so the ellipse, this is the set of all points in a plane whose distances from two set points sum is constant. So that's actually like the like construction of a proof, if I were to put like two thumbtacks on both of my foci here and attach them with a string and then put a pencil in that string and just glide it around where those 2 points are set, that will form my full ellipse. Okay, a couple of other things going on here. So I've got my two foci, I've got my center. This is my major axis, this is my minor axis. These 2 points on the edges of the major axis, these 2 points here, these are my vertices. There is not, I don't know if there's a name for the points on the minor arc. No, or the minor axis. These 2 points don't have names. They're exciting. They're important. But the vertices are always on that major axis, the longer one. Then the kind of the last big thing, the distance, well, the last three things, I guess. The distance from this top point here to the center, and it'll be the same on the minor axis. It'll be the same down here because it's symmetrical. This distance here is B. So kind of the change in Y from the center to the top. The distance from the center to a vertex is A. And then the distance from the center to a focus is C. And these are the same to the left and the right, right? So if this distance is C, then this distance is also C. If this distance is A, this distance is A. So then like you can find the length and width, max length and width of your ellipse using that. So like the whole length of the ellipse is 2A across the major axis. And then the whole height is 2B of the ellipse. And we're actually going to jump, I'm going to give you an equation for an ellipse, like the basic equation. And we're going to do a very similar thing where today, all of the ellipses we're going to talk about are centered at the origin. The next lesson, it'll be translated around. But here's your basic equation with the center at 0, 0 for an ellipse. Here is your equation. And there are proofs of this. If you're curious, go ahead and YouTube the proof of the ellipse equation. And so keeping in mind too that like what this is, x squared will stay x squared. A is this distance from the center to the vertex on the major axis. And then B is this, this length from the center to the top, I guess, half of the minor axis. And then one key relationship here is that C squared is the absolute value of A squared minus B squared. The absolute value is only here because sometimes a graph is taller than it is wide or wider than it is tall. So because it's a distance, it'll always be positive. Okay, so knowing these two things, my equation and that relationship relating the distance to the focus to the rest of them, let's do two examples. All right, so I've got 4x squared plus 9y is 36. Now, notice that the equation has a 1 here, and this is a 36. So to get this in my ellipse equation, my standard form, I need to get this equal to 1. And subtracting 35 from both sides would do that, but that's very messy. Instead, I'm going to divide by whatever is over here, divide everything by 36. And then let's go ahead and reduce our fractions here. So 4/36 will reduce to 1/9. And 9/36 will reduce to 1/4 equals 1. if I just give you an equation up here, how to tell that this is an ellipse equation, reminder that the parabola only had one of these things squared. The ellipse will always have both. Both of them will be squared to be an ellipse. And it said equal 1, so that is our equation. Okay, so then let's find what's A, what's B. So A squared is 9. So if A squared is 9, then A is 3. B squared is 4, so B is 2. And then, yeah, let's go ahead and graph it as it is now, just to kind of start visualizing. So here's my XY graph. The A is going to be my like X dimension, 1, 2, 3. If A is 3, here's my center. One of the vertices is going to be out here at 3, 0. And then 1, 2, 3 is going to be my other vertice, negative 3, 0. Your B is 2, so it's going to go down 2 and up 2. 0, 2, and 0, negative 2, right? So your ellipse is like this. Careful when you're drawing it. You want to go through each of these almost at a straight line. Ooh, okay, nice little bean. And this is great. And then from there, I need to find also the focus. So the focus is the distance C away from the center. So I need to find C here. So let's use that equation there. C squared is the absolute value of A squared minus B squared. So plug in everything that you know. C squared is 3 squared minus 2 squared. So 9 minus 4. Absolute value of that is just going to be 5. So if C squared is 5, then C is the square root of 5. For graphing purposes, approximately 2.2, 2.2-ish. So this focus from the center is going to be 2 and a little bit away. That's your focus. And this focus over here is going to be 1, 2.2, right about there. Your two focuses are there. I'll want to have those as written out as a coordinate point. So your foci, from the center, it's going to go over, so square root of 5, 0, and negative square root of 5, 0. So that's how much it moved to the left and to the right. All right, here's another example. I lied, we're going to do 3 examples. What time is it? Okay. X squared over 16 plus y squared over 49 equals 1. Already set up for us. A is 4, B is 7. So when I'm graphing this, there's no left and right change. A is 4, so I'm going to go over 1, 2, 3, 4, 1, 2, 3, 4. These are not my vertices because this is a minor arc. I know that because, or minor axis. I know that because A is smaller than B here. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So your ellipse is going to look like this, an up and down one. Beautiful. Now let's go ahead and find our focus. So the focus is going to be on, it has to be on our major axis here. It'll be somewhere here. So let's check. C squared is A squared minus B squared. Plug in everything you know. So C squared is then 16 minus 49, which is 33. Negative 33, which is just absolute value is positive 33. So C is the square root of 33. The square root of 33 is approximately 5.7. A good tell for you to decide if like I've done my math correctly so far or not is the focus has to be trapped inside this ellipse. If you ever get a number bigger than 7, something is wrong with the math there. So 1, 2, 3, 4, 5.7-ish. It'll be right there. And 1, 2, 3, 4, 5.7-ish. Be right there. Those are your two focuses. So to define that, those points, right? So this is the point 0, 7. This is the point 0, -7. Over here, we've got -4, 0, and 4, 0. The foci are going to be 0 because it's on the y-axis. So the point 0, root 33, and the point 0, negative root 33. Some people write this as like 0 plus minus root 33. That's fine too. These are the same thing. All right, last example. What if I give you some clues? What if I give you some clues about this? So I'll say the two foci are at the point 0, -3 and 0, 3. And the minor axis length is 4. Okay. So I know a couple of things here. Because of this, I'm just going to graph what I know real quick. Because the foci are at 3 and -3, they have to be on the major axis. So I know this is going to be a taller and skinnier ellipse. And then the minor axis length is 4. If the full length of the minor axis is 4, then B is going to be 2. B is going to be half that. So then I know that like the edges on the minor axis here are going to be 2, 0 and -2, 0. Okay, so now I just have to find what A is, all right? B is 2, C is 3, what's A? So if I were to plug this into my bigger equation here, C squared is 3 squared. I can leave that as A minus, jumping ahead, 2 squared. Now, if I'm thinking about absolute value, I know that A is bigger than B, so this will end up being a positive answer. I can just go ahead and drop those absolute values because I do know that A will be greater than 2 because it's the major axis. Let's add 4 to both sides. A squared is 13, so A is the square root of 13, which is about 3.6 for graphing wise. Now, thank goodness that I know that I have a hint that this is correct because it is a little bit taller than the focus. If it were less than 3, then the focus would be outside of the ellipse, and I would know that's not correct. Your focus here was at the point 0, 3, and here 0, -3, right? So then your two vertices are going to be just a little bit further at like 3.6. So this is the point 0, negative root 13. And up here, again, just like almost like 0.6 above-ish, this is the point 0, positive root 13. And this is going to be my vertice that the ellipse will go through.